Now let's jump out into the code window here and let's build some variables, or let's create some variables. And I just want to show you the syntax here and point out a couple of little things. You do have an option or two here, and the bottom line with these options, pick one and stick with it for continuity, readability with your code, and all this sort of thing. Now when I want to create a variable, I've already mentioned it, and you're going to see this a lot all over this course, and so this particular project or example will not be in your work files folder. Like I said, you're going to see this quite a bit. But if I want to create a variable called a, or yeah, we'll go with a, and I want it to be an integer, I'm going to put int and then the variable name, okay, and then I can put a semicolon. Now what this has done is created a variable called a, but I didn't initialize it to any particular value. Okay, but before I do that, let me delete that and let's do something a little different. I can do integer a comma b comma c and go to the next line, and notice the semicolon at the end. This is going to create a variable called a variable called b, and one called c, and notice they're all of the data type integer. Now you will see this out there. Most people generally don't like to do it that way. It will work, but it tends to be somewhat confusing when you come back later and try to read it. Okay, now what I really should do anytime I create a variable is give it an initial value. Now if I do int a equals 3 and a semicolon, I just created a variable out there called a, and it came into being with a value of 3. Now what if I didn't want it to be 3? Well, then it's always safe to just bring it in as 0. That way you don't get surprised or introduce logic errors into your code. Alright, now that's pretty straightforward, and you will see variables initialized this way, and in this instance we're going to initialize it to 5, and yet there is another way to initialize our variables, and this is called functional notation, and you will see it this way. And this is where we create a variable called a, and then it looks just like kind of a function call, just like that. Now this is the same as saying, okay, I want to create a variable called a, I want it to be a data type integer, and I want it to have an initial value of 4. I'm just not using the equal sign. You will see this a lot. This is popular out there. Either one of these will work. Doesn't matter which one you use, but again, generally you should pick one and stick with it so that it's very easy to pick out your variables and initializations and stuff in the code. Now, that's a variable, and we can then use that variable to print and to do all kind of things, store values, calculate and all, and you will see plenty of examples of that as we move through the course. But then there's another thing. We talked about constants. If I put the const keyword in front of this, then this meant that a is equal to 5, and for as long as this program's running, a can only equal 5. Okay, we'll get into scope and some things a little bit later, but for now just go with what I told you. Okay, constant means that a is equal to 5, and in this instance I'm creating basically two with the same name here. Constant b, and I will use functional notation there, and this is a constant integer b is 6. Now what's going to happen is if I try to do a constant without initializing, it's going to say, hey, wait a minute, dude, whoa, you're going to have to put an initializer in and tell me what it to be, because once I set that thing equal to 7 right here, then as the program runs you cannot change it. It is a constant variable. It is really what we'd call read-only memory at that point. We got to write into it one time when we initialized it. Okay, so that's as simple as it is on creating your variables. You are going to, let me take this away, you're going to put the data type, the variable, in this case it's b, and then an initializer. Okay, either the parentheses or the equal and the value. Okay, now you can also, you don't have to go with these individual letters like I'm doing here. You could have said, the variable is lemon. Okay, and so now I've got a lemon out there, and I could have done apple and set it equal to 3, and then later on I can add apples and lemons. Okay, but that's all I want you to see is how to declare these. You will see these a lot as we go through the course, and you will see us using variables a lot. Now let's talk about data types. Understanding data types is going to be fundamental to writing good, efficient code. And so in this two-part video, I'm going to cover data types. Now in part 1 we're just going to kind of talk about data types, and in part 2 I actually want to go through a list and show you some of them, okay? But first of all, understand that when I create a variable, I'm going to assign that variable a data type. Now we've talked about that in previous videos. What I want to really hone in on these 2 videos is exactly what different data types are out there and how you should use them. Well, a data type determines 2 things. Number 1, what kind of data we can store in a variable, and then actually how much data that variable can hold. Now let's go back to the first one. The data type for a variable is one of the first things that we're going to do, one of our first lines of defense against bugs in our code. Because if I set a data type of, say, a float, some sort of floating point data type, then that means that I'm going to have decimals and fractional values in there, all right? Well, if I just arbitrarily change that data type somewhere in my program to an integer data type, then that means it can only store whole numbers, and it's going to drop off, you're just going to kind of lop off those fractional numbers and throw them out of the way. Now that's going to create a mathematical problem in my program, or an inconsistency or an erroneous calculation. But if the compiler's not watching out for that, it won't throw an error, and that could be really hard to chase down. So one of the first things that we do is we watch our data types and we kind of police those and then make sure that the data that we put in there is the only type data we can put in there, and it can't inadvertently change. Now we can explicitly convert it, but we have to be very careful about how we just change it, and we'll talk more about that a little bit later on. Now the next important thing that a data type does for us is it determines how much data a variable can hold. Different data types create variables that consume different amounts of memory. Now the best way to think about this is to think about your attic or your garage, wherever you store all your junk, and I know you've got junk, okay? Because if you're going to store, say, 5 or 6 pairs of shoes, these are your favorite shoes, you don't want to get rid of them, so you put them in a box. Now you don't want to use a box that takes up half the room just to store those 5 or 6 pairs of shoes. You want a box just big enough to hold the shoes and no more. We want to do the same thing with our data types. We want to use a data type that will store our number or our characters or whatever, but we don't want to waste a lot of memory space for storage that we don't really need. Okay, so we'll talk about that in part 2 when we look at the space on the actual data types. Well, understand now in C++, the ISO IEC standard C++ provides fundamental data types, and then when you jump over into the CLI world, or quote the Bill Gates world if you will, there's a few additional data types. Okay, now I'm going to concentrate in this 2-part video on the ISO IEC standard types. Okay, now there are 3 categories of fundamental data types in ISO IEC, and let's look at those here. Integers, and these are whole numbers, right? Non-fractional numbers, positive or negative. Then there's non-integral values, and in English that means floating point or decimal numbers or fractional numbers. And then there's void. Now we won't go into void in these 2 videos, but just understand that void means there's an empty set of values or there's no type at all been assigned. It just means nothing's there. All right. Now in part 2, I want to actually go through the various data types and kind of give you an idea of what you need to know on these things, all right? Because part of being a good programmer is knowing what data type to use when. And that way you're managing your memory efficiently, you're managing your code efficiently, you're helping your code to run faster, more efficiently, just all kind of cool things are happening. So if you'll join me in part 2, we're going to start right here on this screen, and we're going to go through some of these fundamental data types. Welcome to Data Types Part 2, and we're going to start right where we left off in Part 1. You might have seen a little teaser of the different data types that were out there at the end of Part 1, but let's start with the integer data types. Now we're going to talk about integers and floating point values in this video. But what I want to do is go through these data types and let you see the differences in them and kind of make some lights come on about how you can use these. Now if you've been around programming a while, you've seen this, you know this, and you may just want to go on by this video, all right? But if you're new to this or you haven't been in C++ for a while, you may want to take a look. First of all, there is an integer data type called a bool, that's short for Boolean, and that is, notice it takes 8 bits. 8 bits are in a byte, so this is a 1 byte data type, okay? And it stores a 0 or a 1, so we can use this to designate zeros, ones, true, false, yes, no, that sort of thing. Then there is a char or a character data type, and this stores 8 bits, 1 byte. And notice in the char we can store, remember in the videos a little earlier in the course we talked about signed and unsigned data types. If we're using it as a signed data type, the char will store from -128 to +127. So if we're going to create a variable that's going to store the store locations, and we have these in code numbers, all right, as long as we don't have more than 255 stores, then we can use an unsigned char to store that, all right? So we could easily make that happen. Now notice with a short data type, this is 16 bits or 2 bytes, and notice the signed version of a short, or the signed integer type modifier, gives us from -32,768 to +32,767, and if we use that as an unsigned data type, then we can go 0 to 65,536. So again, if we're storing the annual salaries of our employees, as long as nobody makes over 65,536, we can get away with using the short data type to store that. Now what's going to happen? The minute we try to store 65,537, we're going to get an error, and it's going to say overflow, that sort of thing. Now the integer data type, int, or long, either one of these means really the same thing. 32 bits, all right, 4 bytes. Notice you can store from -2 billion and some change, I won't read it all to you, to +2 billion as a signed data type, and if it's unsigned, you can go all the way from 0 to +4 billion and all of that, all right? Doesn't seem right to call 294,000 and something else change, but that's what we'll stick to. Then the long data type is 64 bits. Notice that's 8 bytes, and I won't even try to read this number. It's -9 quadrillion up through +9 quadrillion, and a whole lot of change, okay? So for really large numbers, the long data type. You won't see that very much, simply because do you really want to use 64 bits of memory to store, you know, people's age and all that sort of thing, all right? So that's the long data type. Now when we start to talk about floating point data types, the first one is a data type called float. Notice these get rather large. This is 32 bits in size, and the range, now notice this, and you have to kind of watch this. It looks like it's kind of weird, but you have to multiply it out. This is a negative from 1.4023 times 10 to the -45th power, that's a large number, to 3.4028 positive times 10 to the 38th, okay? So that's 3.4028 times 10 times 10 times 10 times 10 times 10, large number anyway, okay? The double is 64 bits in size. It goes from 4.9406 times 10 to the -324th power to 1.7977 times 10 to the 308th power. Now, how big of a number is that? And that's our two choices, float or double. Keep in mind that we can express our floating point values as a decimal value, for example, 234.5, or we can express it as an exponent as 2.345 times 10 to the second power. So notice that means 2.345 times 10 makes it 23.45 times 10 again makes it 234.5. So you can see when we're talking about 34 times, we're getting to some really large numbers. Now you can adjust in there how many decimal places you want to show and all that, and have all kind of leeway and all kind of adjustment room with these things, okay? But that's your fundamental data types, and you need to kind of get these in your head and make sure that you're using a data type that stores the values that you need but doesn't leave a lot of empty headroom out there where you're just kind of wasting memory, okay? So anyway, that's your fundamental data types.